This lesson is about the terms and definitions used in testing and the measuring process. And hello again to this lesson, which essentially has two learning objectives. At the end, you should know the main terms and definitions used in testing. And you should know the main terms and definitions used specifically for the measurement process. This lesson is divided into two chapters. In the first chapter, we look at the terms and definitions used in testing, and in the second chapter, we will talk more specific about the terms and definitions in the measurement process. Let's start with the main terms and definitions used in testing. In general, testing is about determining the extent to which a test object meets a requirement. Such a test object could be the piston shown here, for example. A test feature on the piston is its diameter. The requirement for this diameter is the nominal size with its tolerance. A test can now be done either by measuring or by gauge. The result of a measurement determines the actual value of a characteristic. This result always has a value and a unit. A test with a snap gauge, for example, determines only if a characteristic is within a specification or not. The result is just a pass or fail. Measuring or using a gauge are objective tests. This means they are independent of the appraiser's judgment. Examples of objectively measurable basic quantities are, for example, those of the International System of Units. Time in seconds, length in meter, mass in kilogram, electric current in ampere, thermodynamic temperature in Kelvin, amount of substance in mole, and luminous intensity in candela. Subjective tests, on the other hand, are the individual perception of the environment by the observer through his senses. A substance can be perceived as strongly pungent by a person's sense of smell. Another person might just describe the smell as unpleasantly burning. Of course, different test equipment is also used for the three types of tests just discussed: measuring, gauges, and the subjective test. For example, when it comes to the diameter of the piston, we speak of a variable characteristic. Its value can be 60.1 mm or 60.2 or any value in between. The result of a measurement, for example with a caliper or a micrometer, is always a numerical value with a unit. But the same characteristic can also be checked attributively. This means that it is only tested whether the feature meets the requirement or not. A suitable test device for this would be a limit snap gauge. In the case of subjective tests, the test equipment is the sensory organ of a person. So, for example, the eye, the ears, or the sense of smell, and so on. Here is an overview of the test results already mentioned. The result of a measurement is a measured value, for example, 60.12 mm. A measurement is only an approximation of the true value and should include a value for the measurement uncertainty. With the value of the measurement uncertainty, an interval can be calculated within which the true value of the measured variable is expected. More on this in the following lesson. Let's now turn to the terms and definitions relating to the measurement process and the measurement system. The measurement process is defined as the set of operations to determine the value of a variable characteristic. The measuring system is the complete set of measuring instruments and any other equipment used to carry out the measurement. For example, measuring instruments, measuring object, appraiser, devices, auxiliary apparatus, process instruction, software, and the environment. Measuring equipment can be a measuring instrument like a caliper or micrometer, but it can also be measurement standards like gauge blocks, gauge pins, reference materials, or an accurate measuring device used in the measurement or used to calibrate other measuring devices, or any auxiliary apparatus or instruction, and so on. As we just saw, the measuring instrument is only one part of the measuring or test equipment. A measuring instrument is a device used for making measurements alone or in conjunction with one or more supplementary devices. An example would be such a digital multimeter for measuring the electrical current, voltage, or resistance. The resolution of an instrument indicates the increments in which a measuring instrument can reproduce measured values, so it can clearly differentiate between them. The higher the resolution, the more different values can be displayed in a measuring range. As an example, the digital display could show the electrical current with the resolution of 1, 2, or 3 digits behind the comma. The resolution of the display is not synonymous with the measurement accuracy, which we are now coming to. A characteristic like the diameter of a piston has what is called a true value. The true value of a variable characteristic would be obtained with an ideal measurement. However, the measured value that is measured deviates from this true value. This is because various influences can cause variations in the measurement. This results in a measurement error. Therefore, a measurement result is only an approximation for the true value. Hence, the result should also include the measurement uncertainty. More on the measurement uncertainty will follow in one of the next lessons. Finally, a few words about calibration and adjustment, since these terms sometimes lead to confusion. When calibrating, there is no technical intervention on the measuring equipment. Calibration is a comparison of a measured value to a traceable measurement standard, a reference value. The measurement deviation, also accuracy, is documented in percent or a unit on a calibration certificate. When adjusting, on the other hand, there is an intervention on the measuring equipment. Adjusting is a set of operations carried out on a measuring system so that it provides prescribed indications corresponding to given values of a quantity to be measured. Well, that was a lot of new information. Therefore, I would like to conclude by repeating the 4 most important key messages. Measured values deviate from the true value because various influences cause a measurement error. The test result of a variable characteristic is a measured value with a unit and an indication of the measurement uncertainty. Calibration, no technical intervention on the measuring equipment. Comparison of a measured value to a traceable measurement standard, reference value. Adjustment, with technical intervention. Set of operations carried out on a measuring system so that it provides prescribed indications corresponding to given values of a quantity to be measured. If you found this lesson helpful, please let me know and leave a comment. Thank you for that. Take care and see you next time. Bye.